Another type of organic synthesis. Again, more practice. So I'll take a, let's say, can I take a pentene? 1, 2, 3, 4, 5. Now pentene, this is pentan. This is iodopentanol. Yeah, what does 1 second? 1, 2, 3, 4, 5. I'll do that, yes. Okay. So I'm going to take iodopentanol, iodopentane, 2 iodopentane. This is I, the element iodine, okay? And what we'll do is we'll duplicate this to replace the I with, let's say, OH. Okay. So I'm like, okay. Reaction 1, reaction 2, then reaction 3. I'm going to say I'm giving you acidified KMnO4 and heat. Actually, no, forget yeah, it's fine. KMnO4, heat under reflux, and makes 1, 2, 3, 4. 1, 2, 3, 4, 5. It'll make C5H10O. And you are supposed to come up with the structure for C5H10O. There's a reason why I'm giving it like that. You'll see why. Because sometimes they'll give you that, and then you'll have to figure out, okay, what's changing in terms of the formula. So that's what's being added. So sometimes to understand why they give formulae, you'll have to figure out the formula for the rest of them. Okay. And then I have another reaction right here. Let's call it 3. This is 3. Let's call this 4. And 4, I become 1, 2, 3, 4, 5. C5H10. And then I become C5H12. That's reaction number 5. And then reaction number 6 becomes C5H11 Br. Okay. Now some of these reactions are repeat from earlier synthesis and some of them are new. Obviously, now new in the sense that we haven't done them in this synthesis, but we've done the reactions already. So here is this fellow. I'll bring this down again. I'll duplicate this also. So when I make the boxes, you have to come up with the figures. Okay. And here also you got to come up with the figure. Yes, in nice diagrams. I'm enjoying my drawing in this one. So let's figure these one out. Okay. Yeah. I'm aligning them because I have OCD about alignment, so I'm doing that also. So reactions 1, 2, 3, 4, 5, 6. Oh, this is beautiful. Now I'm like, hey, how do I do this stuff? Okay, I can give you some hints. Okay. Like for example, 4 requires NaOH in some form. Okay. 5 is reduction. You can figure that one out. And 6 is a form of substitution. Let's see if you guys can figure this one out. And so for reactions 1, 2, 4, 5, and make the boxes, come up with the reagents conditions and even the, yeah, that's what we do. Now in reaction number 1, I am replacing the I with OH. So that is NaOH aqueous, heat under reflux. That is the nucleophilic substitution, hydrolysis of halogenoalkanes to alcohols. Reaction number 2 was also substitution, but you could use HI or red phosphorus and iodine and heat. That's reaction 1 and 2. 3, you have a secondary alcohol. This is secondary alcohol. So when I use KMnO4, what happens? The secondary alcohol gets oxidized, but to what? What does secondary alcohol get oxidized to? It can't be an acid. It has to be a ketone. So it becomes a double bonded CO, ketone. That's it. And the formula fits. CH3, CH2. The formula just tells me, you want to figure out the formula. It tells me that there's only one O. So it can't be an acid, because acids have two O's. That was the hint right there. And CH3, CH2, CH2, CO, CH3. That's the structure. That's the formula is only given to double check your answer. So look at this fellow, CH3, CH2, no, sorry. CH3, CH2, one more CH2, and then CO, CH3. When you count this, 1, 2, 3, 4, 5 carbons, yes. Hydrogens 3, 4, 5, 6, 7, 8, 9, 10, yes, and 1 oxygen. So this structure is correct. But then when I want to make C5H10, when I do this guy's formula is CH3, CH2, CH2, CHI, CH3. When I work out the molecular formula, my original compound is C5H11I. So the reason why they give the formula AR to figure out what's lost. When I look at compare the two formulas, I am realizing that reaction number 4 is removing an H and I. When you remove something, what is it? It's elimination. Now how do I eliminate an halogenoalkane? Oh, he's given NaH also. So it must be NaOH in ethanol. Heat under reflux, remember? And so then, what is my alkene? Now I have one of two options to make the alkene. That's the beauty of it. You can give either or. Okay? You can remove the I and make the double bond there or there, wherever you like. Because now they're only needing one option. So you can make the double bond right there, if you like, here. Yeah. And then, how do I go from C5H10 to C5H12? What do we see happening here? I'm adding two H's. How do I add two H's? Hey, I remember that's an alkene adding two H's. How do I do them? Hydrogen and nickel and heat. That's how you add two H's. And now what do I have in here? I have an alkane. This is pentane. And then pentane replaces one hydrogen with one bromine. Remember how alkanes undergo substitution? They undergo free radical substitution. So what do you need? You need Br2 and UV light. And you can put your Br anywhere here. So there are multiple correct options. You can put the Br there, Br there, Br here also. Anywhere. It doesn't matter. That would be an acceptable answer. So now I have also introduced two alkane reactions. One alkene to alkane, one alkane to halogenoalkane also here. From iodoalkane to alcohols to acids also. To ketone. And one reaction that we haven't talked about much yet is this backward reaction. Okay. This is reaction number 7. This is ketone to an alcohol again. You remember how to do ketone to an alcohol again? That's reduction. And how do I do that? I take NaBH4 aqueous and heat. I can reduce the ketone back to the secondary alcohol.